Dear students, welcome to chapter 3 temperature basics 2, that is air temperature basics 2. In this class we are going to learn very interesting, more interesting topics such as temperature distribution, the temperature and climatic zones, and factors affecting air temperature. These three we are going to discuss. It's very interesting. Just before we go into the class, I just tell you a small story. A great city was besieged and its inhabitants were called together to consider the best means of protecting the city from the enemy. The city was besieged by enemy. So all the inhabitants came together in a group of them. The leader asked, "Can anyone please suggest me a very good bricklayer who has wonderful skills, has name and fame in that area, earnestly recommended bricks as affording the best material for effective resistance from the enemy. A carpenter who has wonderful experience, has name and fame, with equal interest and enthusiasm, proposed timber as a preferable method of defense. The bricklayer suggested bricks as affording the best material for effective resistance. An excellent skilled person having knowledge on timber suggested timber. Then an industrialist who has wonderful experience using leather suggested that no material for resistance equal to covering of heights and nothing so good as leather." So what is the moral? Every man for himself. Every man for himself is the moral. Now coming back to our class, let us discuss. As I said, in this class we are discussing temperature distribution, temperature and climatic zones, and factors affecting air temperature. It's very interesting. Now, what is temperature distribution? Temperature distribution means on the earth, equator is there, poles are there, the latitudes are the lines, imaginary lines drawn parallel to the equator. Okay, so the temperature distribution means the temperature at the equator, the temperature at the poles, in between equator and both the poles, North Pole and South Pole, the temperature goes on varying or changing. This is what we call it as the temperature distribution. There are basically three types of temperature distributions. How many ways and means of temperature distribution are there? Three. Number one, horizontal temperature distribution. Temperature distribution is described in three ways or three types. One, horizontal temperature distribution. Second one, periodical temperature distribution. In between we have vertical temperature distribution. Horizontal, vertical and periodical. Now, each one I try to explain to you in a very simple way because this is the basic course. Now, the sun's rays make different angles at the same place but at different times. Also, different angles at the same time at different places as the axis of the earth makes an angle of 23.5 degrees with the vertical. Okay. Due to the variation in angle of the sun's rays, the distribution of solar heat on the earth decreases both ways from the equator to poles. This is known as horizontal distribution of air temperature. Simple line I will tell. When you go from the equator towards North Pole or Southern Pole, the temperature goes on decreasing, decreasing and decreasing. This is known as horizontal temperature distribution. Okay. The horizontal distribution of temperature on maps is shown by isotherms. Easy to remember. Temperature therms, isotherm. On map, the horizontal distribution of temperature is shown by isotherms. By definition, isotherms are imaginary lines drawn connecting the points that have equal temperature. Once again, for your benefit, isotherms are imaginary lines drawn connecting points that have equal temperature. Now, there are certain factors influencing the horizontal distribution of temperature. Latitude, ocean currents, mountain barriers, topography and relief. These are the factors influencing the horizontal distribution of temperature. The first one is the latitude. As I said, when you go from equator to both sides, okay, northern pole or southern pole, the temperature goes on decreasing. That means the effectiveness of incoming solar radiation in heating the earth's surface is largely determined by the latitude. So, there is a general decrease in temperatures from the equator to poles. This is a classical example of horizontal temperature distribution. Latitudes, when you go from equator to both the poles, the temperature goes on decreasing. The first factor is latitude. The second one is ocean currents. The transport of ocean water in the form of currents carries heat from one part of the earth to another, which results in horizontal distribution of sea surface temperature. That means ocean water in the form of currents. Ocean water. It carries heat from one part of the earth to another part. That means, like latitude, when you go from equator to both sides, the temperature goes on decreasing. Now, the air temperature is also influenced by ocean currents. Now, the next one is the mountain barriers. Mountain barriers at a large scale. Himalayas protect India from polar air. It is a classical example. What is exactly happening? Mountain barriers and ranges tend to guide the movement of cold air masses, resulting in horizontal temperature variation. So, the next one is topography and relief. In the northern hemisphere, where we are all living on the northern hemisphere, the north facing slopes generally receive less insolation than south facing slopes, and the temperatures are normally lower. What exactly does it mean? If you just take Vindhya ranges facing south, what happens? In the northern hemisphere, the north facing slopes are generally expected to receive less insolation. North facing. Vindhya ranges facing north, that means Himalayas, they are cooler. Vindhya facing south usually have high temperature. This is the topography and relief. That means the factors influencing horizontal distribution of temperature are latitudes, ocean currents, mountain barriers and topography and relief. Now, let us discuss about vertical temperature distribution. Very interesting. If you go to Himalayas or high mountains, you will find always snow caps and snow caps. Why? Because vertically, in the first chapter I told, in the troposphere, for every 1 kilometer, the average temperature decrease is 6.5 degrees centigrade. Okay, that is called vertical temperature distribution. Now, the vertical distribution of temperature is due to adiabatic lapse rate. An adiabatic process is one in which the system being considered does not exchange heat with its environment. The most common atmospheric adiabatic phenomena are those involving change of air temperature due to change of pressure. Now, the rates of adiabatic heating and cooling in atmosphere are described as lapse rates. That means the rate of change of temperature due to rate of change of pressure is known as adiabatic lapse rate. The rate of change of temperature due to rate of change of pressure is known as adiabatic lapse rate. Say for example, the adiabatic lapse rate for dry air is nearly 1 degree centigrade for 100 meters or 10 degrees centigrade per kilometer. That what exactly does it mean? If you go out of this classroom, stand on the stand on the surface of the soil and look at the sky for 1 kilometer. If the distance between your feet and 1 kilometer is completely dry, the fall of temperature at 1 kilometer height is 10 degrees centigrade, dry air. If it is wet, then it is 5 degrees centigrade per kilometer. However, the average adiabatic lapse rate is 6.5 degrees centigrade. It is not 10 plus 5 by 2, 7.5. It is 6.5. Once again I repeat, when you just go out of this classroom, after our class is over, stand on the surface of the soil and look at, when presume that it is the in and around you, completely dry air is there. For every 1 kilometer height, 10 degrees centigrade decrease will be there. Where you are standing, if the temperature is 30, it will be 20 if completely dry air is there. Where you are standing is 20 degrees centigrade and the rain is occurring, for example, completely wet. Okay. If you go to 1 kilometer height, then the temperature would be just 25. Okay. When you are standing, it is 30. When you go to 1 kilometer, it is 25. When you are standing, it is 20. Where you are standing is 30. When you go up, when the dry is there, 20. That means dry adiabatic lapse rate is 10 degrees centigrade. Wet adiabatic lapse rate is 5 degrees centigrade. And the average adiabatic lapse rate is not 7.5. Average of 10 plus 5 by 2. It is 6.5 degrees centigrade. Okay. This is what we call it as the vertical temperature distribution. Now, what are the primary causes for fall of temperature with higher altitudes? As we go from surface of the earth to some higher altitude, altitude. The major source of heat for air at the ground level is the earth. Clearly, with increasing distance from the source of its heat, the air temperature must decline. Major source of heat is earth. When you are going away from the earth, the temperature goes on decreasing in the troposphere. Second point, the density of water vapor decreases with elevation. So, less heat can be held in the air. Third one, because of lesser pressure. As the height increases, the pressure decreases. As the pressure decreases at a higher altitude, the air expands and becomes thinner and cooler, resulting in fall in temperature. These are the primary causes. Why? There is a fall of air temperature with higher altitude or higher elevations. It is because the earth is the source of heat. As you are going away, the temperature declines, density of water vapor declines, thereby the air temperature decreases, the pressure goes on decreasing, thereby the air temperature is falling. This is what we call it as the primary causes for fall in air temperature with higher altitude. Now let us go to the third one, periodical temperature distribution. First one, horizontal temperature distribution. As you go away from the equator to both sides, 1 degree latitude, 2 degree latitude, 3, 5, 10, 11. Okay, good. The temperature goes on decreasing on both sides. This is horizontal. The vertical, as you just look at where you are standing is 30 degrees centigrade. If it is dry 1 kilometer up your head or feet, it will be 20 degrees, 10 degree fall. Why it is so? Because of vertical temperature variation of dry air. Now where you are standing is 30 degrees centigrade. When in between you and 1 kilometer height into the troposphere, it is wet, raining. The 30 degrees centigrade where you are standing becomes 25 when you go to 1 kilometer. This is a vertical temperature variation. What is periodical temperature distribution? The air temperature changes continuously during the day, week, month or a year. Temperature of the air goes on changing. Of course, there are two ways for periodical. Periodic means periodic, day, week, month, year, like that, periodic. First let us take mean daily cycle of air temperature. What exactly? In a day, the air temperature changes. When the sun rises, the insolation is supplied and the air temperature starts continuously rising. 6 o'clock, temperature is 20. Maximum temperature occurs anywhere between 1 p.m. and 4 p.m. say around 2:15 in the afternoon. The temperature is 30. Morning 6 o'clock 20. By 2:30 it is 30. Of course, after 2:30 it goes on decreasing. Why it goes on decreasing? Because maximum insolation is received around noon, but maximum temperature is recorded from 1 or 2:15 or in some places 4 p.m. The delay between maximum insolation in the afternoon to minimum temperature that is recorded from 1 to 4 p.m. it is known as a thermal lag or thermal inertia. Okay. So, mean daily cycle of air temperature, morning when you get up in your hostel, 20 degrees centigrade. 2:15, good, 30 degrees centigrade. Take it for granted that there is a lag between the soil temperature and air temperature that we discussed in the soil temperature. Now, the second one in the periodic temperature distribution is the mean annual cycle of air temperature. Mean annual cycle. In an annual cycle, annual temperature changes from one location to other. In the northern hemisphere, winter minimum occurs in January and summer maximum occurs in July. When loss of long wave radiation exceeds the short wave radiation received, then the temperature falls. And under a reverse of this situation, the temperature increases in a cycle. Okay, so what exactly does it mean? We have basically 3 seasons in tropical countries, 4 seasons universally. The first one is, as far as tropical areas are concerned, the rainy season, the winter season, the summer season. Now, in the summer season, the average temperatures are 35. In the rainy season, the average temperatures are 30. In the winter season, the average temperatures are 20. That means mean annual cycle. So seasonal variations of temperature, we call it as the periodic temperature distribution, mean annual cycle. Okay, so this is what I would like to enlighten you on: horizontal temperature distribution, vertical temperature distribution, and periodical temperature distribution under two headings: mean daily cycle of air temperature, mean annual cycle of air temperature. The last two small subheadings for today's class left over are temperature and climatic zones. The climatic zones on the earth are tropical, subtropical, temperate, and alpine. Tropical, subtropical, temperate, and alpine. These zones are differentiated on the basis of temperature. The tropical zone is a hot, winterless zone. Tropical is hot, winterless zone. Subtropical zone is hot zone with a cool winter. Subtropical is also hot zone, but there is a hot zone with a cool winter. Temperate zone is with a warm summer and pronounced winter. And the alpine zone, the last one, has a very short summer and a very long and severe winter. Okay, tropical means a zone which is very hot and winterless. A subtropical zone is again hot zone but with a cool winter. Temperate zone is having a small warm summer but pronounced winter. And finally, the alpine zone has a short summer and a long, severe winter. Now, the last part of today's class is factors affecting air temperature. Factors affecting air temperature. Now, simply there are 10 factors: latitude, altitude, distribution of land and water, ocean currents, prevailing winds, cloudiness, mountain barriers, nature of the surface, relief, convection and turbulence. Once again, I just try to enlighten. There are 10 factors affecting the air temperature: latitude, altitude, distribution of land and water, ocean currents, prevailing winds, cloudiness, mountain barriers, the nature of the surface, relief, and convection and turbulence. Okay, thanking you very much.